Hello, 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 everybody, and welcome back. Root Beer here with question number 9 on the 2006 Grade 8 Gauss contest. That's the Grade 8 level, not the Grade 7 level. That's a different set of videos. But hopefully you've given question 9 a try. Let's look at it together now. In the diagram, AB and CD are straight lines. All right. The value of x is, so we got x down here in the corner. He's the corner of sort of a triangle right here. And we're being asked what's the value of x. So we've got some other angles here, 50, 60, 120. I can think of two ways to do this question right now. I'm going to show you both. One is probably the more obvious way to do it, but it's going to take a little longer. And the second way is very fast, but you sort of need to understand how some angles and lines work with one another. Okay, so the first way is sort of chasing down various angles in here. Okay, so what can we do? We'll copy our picture here. Now A and B look like they're parallel, that they'll never touch, but they never actually tell us that in the question. So we'll draw them. They sort of look parallel. And in fact, the second way of doing this actually talks about, why are these lines parallel? And we want x down here. Okay? Well, we have some other angles that we might be able to use. Okay? For example, if we knew this angle over here, this blue angle, 180 degrees makes up a full line. So it would be 180 minus the blue angle is equal to x. Okay? Similarly, we have a straight line up top here. So the red angle plus 60 and 50 has got to be equal to 180. And we'll use green down here. We have another green angle, and that plus 120 should be 180. Okay? So probably the fastest way to get x is actually not to get this blue angle, although it might be tempting, but to get these two angles, because then we have a full triangle in here, and the sum of the angles in a triangle is 180 degrees. Okay, so 120. So this guy here is going to be 180 degrees minus 120. He's 60 degrees. We'll actually need that for the second method we do as well. This one up here, he's 180 degrees minus 50 minus 60. So he's going to be 180 minus 110. He's going to be 70 degrees. And now x degrees is going to be 180 degrees inside the full triangle. This triangle right here, minus the other angles in the triangle, 60 and 70. And you can grab your calculator, you can work it out by hand, you're going to get 50 degrees. Okay. So our answer would be 50 degrees A. Now, I said there's another way we can sort of work this one out. We only need to do one calculation. As I say, these guys look like parallel lines, so this is a different way to do the question, using a bit more advanced sort of angles and straight line sort of work. So we've got 120 degrees here, we got 60 degrees here, 50 degrees here, and x degrees. What we're going to do is we're going to use some theory and explain why x and 50 degrees have got to be the same. Okay? Now, first, let's just look at our 60 and our 120. Now, as we already said, 120, the other one on the side is 60 degrees. And look at right here. We have sort of a Z. That's why sometimes I've seen this called the Z theorem. But if you have some lines and a line that goes across both of them, and these two lines are parallel, then the angles in the corners of the Z are equal. Or if you've got this sort of setup and you know that the angles inside the Z are equal, then these two lines must have been parallel to start off with. Okay? So that's sometimes called the Z theorem. I'm not going to write out a nice big statement for it. But because we've got the 60 down here, that means these lines here are parallel. And if we know they're parallel, then the angles in the corner of this Z here have got to be equal. So x is 50. Okay? It works both ways. If you get the equal angles, these lines must be parallel. If you've got parallel lines, then these angles must be equal. Very quick, very efficient, but we need to know some sort of theory about parallel lines, angles, and the line going across, which tends to be called the transverse line. Okay? And there are some other nice results. I'll show you one more before we move on, because this isn't supposed to be about theory here. But another situation we have here, two parallel lines and another line crossing, you get what's called the F theorem. Because in the corner of this F, these angles have got to be equal. Okay? So you can get the Z theorem, the F theorem, that sort of fun stuff. You can get the C theorem, where the angles in the corners of this, we'll make it green. The angles in the corners of this C add up to 180 degrees if the lines are parallel, that sort of stuff. Okay? Very interesting, very fun, and if you knew that, this question was a breeze. Okay? If you didn't, well, that's okay. You can just use our working out separate angles. I tend to call this diagram chasing. Figure out this angle, then get this angle, then use those angles to get this angle, that sort of stuff. But either way, we get A, 50 degrees. And that's question 9, the penultimate question in part A. We'll finish off part A with question number 10 in the next video. Thanks for watching.